All right, let's look at graphs for a moment. Graphs are visual representation of the relationship between variables. In this class, we will typically create line graphs, and these are going to show the best fit for our data that we have plotted, or maybe the trend so that we can see how a variable changes throughout our experiment. When you create your graph, it will be important for you to scale your x and y axis so that your data covers the majority of the graph space. You must cover at least half of the graphing space, or you will lose points for making your graph too small. So make sure that you scale it appropriately so that you cover as much of the graph space as possible. When we create line graphs, we are able to calculate the slope of that line, and that slope is going to represent additional information or typically an additional variable for us. So when we calculate the slope in math class, we do rise over run, or perhaps you are more comfortable with change in y over change in x. We're going to perform our slope calculation in physics in exactly the same way. We're going to take how the y variable changes, and we're going to divide that by how the x variable changes. So in math, we see that written as y2 minus y1 to show the proper way to calculate the change in the y value. In physics, we will not be using ones and twos, but we will typically choose to say finals and initials. So y2 would be the final of our variable. So let's say that we're looking at a graph where speed is on the y-axis. So it would be the final speed minus the initial speed as our rise or the change in y value for that particular slope of the line. Okay, that is the format that we will use, final minus initial. I apologize that the font came out a little funny over there on the left-hand side, but let's look at the parts of the graph. We'll go ahead and start with the left side of the graph. So the y-axis is going to represent our dependent variable, and that's what that says. And our x-axis is going to represent our independent variable. And notice that both the x and the y labels need to have the name of the variable along with the unit it is measured in. So for this example, the the y-axis is going to be a distance, and it's going to be measured in meters, whereas the x-axis on this example is time, and it's going to be measured in seconds. You must tell me what those units are. Miles and kilometers and meters are all different units of measurement. So when I interpret the data, I need to know which of those units my values are in. You must include both the title and the unit for full credit on any graph that you create in this class. The slope of the line is going to represent the relationship between those two variables. So my slope, which would be the red line here on this graph, could either be a positive or a negative relationship. Perhaps my variables have a direct or an inverse relationship. Perhaps they have an exponential relationship, or maybe they have there's no effect of one on the other, or no real relationship between the two. So these are the things we will be interpreting from that slope. So here we have an example of a graph where there is a positive slope. So this means that my x-axis is increasing along with my y-axis. They are both increasing together. We could also call this a direct relationship, which means that they both increase together. Okay, now there are no numbers on these example graphs, so if you need to, by all means, add numbers to your graph at any time. If you're working on a practice assignment or a test or something, you absolutely could come over here and just give yourself numbers so that it is a little clearer for you. I know for some people, having that concrete information makes a world of difference. So feel free to add that if it's not on there. Here, we're just trying to make sure you understand in general, this is a graph that shows a positive slope, or we could interpret that as a direct relationship between variables. Here we would have a negative slope. So as I increase in value along the y-axis, along the x-axis, so if this were 1, 2, 3, 4, 5, and so on, I am decreasing in value along the y-axis. So if this is 1, 2, 3, 4, let's say up here we're up to 15, as my x-axis increases 1, 2, 3, 4, 5, my y-axis would be decreasing, going down from 15, 14, 13, 12, or whatever those numbers may be. So this would be a negative slope, or we might say that these variables have an inverse relationship. Here we are looking at a graph where there's no change in the y-axis. So we would say that there is a slope of 0. There is no effect is sometimes our interpretation, although we're typically going to be saying here that my y value is, since my y value is constant, we would interpret this as a slope of 0. Whatever variable that slope represents, it would have a value of 0. Okay, and that'll make more sense as we get into some actual physics content here very soon. Here, I want you to look at this graph and recognize that the slope is increasing. So there is a positive relationship here. There is a direct relationship, but it's not a linear direct. This is going to be where it's a direct square. You're not going to have to interpret that too often, but I do want you to understand that that's basically what we are looking at here. So as my x value increases, so does my y, but my y value is going to increase more. So if I have a change from 1 to 2 to 3 to 4, and then here I have my change in y represented, when my x value changes by a value of 1, my y value will have increased by a value of 2, or maybe by a value of 3. In the beginning, it's a 1-to-1, and then maybe it's even a 2-to-2. But then as we get over here, the amount of change on the y-axis is going to be much larger than the amount of change that we would have seen here closer to a value of 1 or 2 on my x-axis. So this would be a positive relationship, and we would say here that my slope is increasing in value. Now, in the beginning, I just want you to be able to tell me that I have a constant negative slope, I have a constant positive slope, I have a slope value of 0 because there is no slope. Here, I want you to recognize that the slope is changing. So in general, can we understand that this is changing? Specifically, it is changing so that it is increasing. So you either know that it's increasing because, as I've explained, the amount of change has increased as we moved along the graph. Another way that you could do this is just simply look at the tilt of the slope. So if I am analyzing the slope of my line at this portion of the graph, that is a very low grade incline, that is not very steep. As I move along the graph, that is definitely a steeper slope here. And then we're almost perfectly vertical by the time we get to the end on this example. So even though I don't have numbers to calculate exactly what these slope values are, I should comprehend that it would be a small value for the slope on the first segment that I've highlighted. It would be a larger value on the second segment, and then the largest slope value would be calculated for the third segment. When we look at this, again, I want you to see that the slope in general is changing. I would also like for you to be able to tell me that the slope is decreasing in value. So this first section that I've highlighted here. It is a very steep slope. When I look at this portion of the graph, we are not quite as steep on that slope. And then when we get over here to the end of our graph, we are almost horizontal. So definitely different slopes. Specifically, they are changing so that the slope is a smaller and smaller value, or that line is less steep as we progress. Now, this is a changing slope, and so hopefully you can identify that right off the bat. But is the slope increasing or decreasing? You have to pay attention to what I am asking you to analyze. I am asking you to analyze the slope, not the y value or the x value. You will be asked to analyze the change in y, and you will be asked to analyze the change in x, and you will be asked to analyze the slope. Those are three different parts of the graph, and so you'll need to make sure you understand what part we are asking you about. So if I'm asking you about the slope, we must recognize, number one, that it changes, but then how does it change? We start with a steep slope. Here it is less steep. Here we are getting quite horizontal, so decreasing in slope value. All right, so this is a decreasing slope. Again, in the future, this will represent an actual variable, and so whatever that variable is, its value would decrease as we move through the graph. This is also a changing slope. That's easy enough to recognize. Here, though, instead of having a decreasing slope, we have an increasing slope. So we are analyzing the slope, not the x or y axis, okay? So we start off with a very low value for our slope. This is not much of a slant. Then our slope becomes more tilted, more slanted, so we would have a greater value here. It becomes steeper. And then here at the end, it is super steep. So this would be an increasing slope. So I just want to backtrack real quick. Here is an example of a changing slope where the value of my slope increases as we move through the graph. And here is an example of a changing slope where the value increases throughout the graph. Make sure that you are analyzing the slope. We are not analyzing the y value. We are not analyzing the x value at this time, okay? So pay close attention to what part of the graph the question is about. For something like this, I would like for you to see that we have identifiable sections. Again, there are no numbers here, but we can clearly see that there is a segment here with some steady slope, and then my slope changes. So let's not pick the same color. So for this segment, I have a different slope value, which in this case it happens to be 0. And then in this segment, I have a third slope value. This is not the same as the first slope section highlighted in orange. Orange was positive, this is negative, okay? So 3 different slopes here, and I just want you to recognize some basics about those different segments. If I'm asking you a question about a graph like this, I will most likely be telling you which segment of the graph specifically to look at for each individual question. Here, I want you to recognize that it's changing. I would love for you to be able to tell me that initially the slope decreases and then the slope begins to increase. It is also changing here. Initially, the slope decreases, and then it begins to increase. Remember, we're analyzing the slope, so we become less steep initially, and then we start to increase that tilt once again, and so there is an increasing slope on the second half of the graph.